Hello, I'm Franklin, and today we will be talking about one of the most smallest things in our universe. Each one of these minuscule objects live in a realm where the laws of physics change. In this realm, objects can teleport, be everywhere at once, and even pop into existence. This realm is called the quantum world, where quantum physics takes over. Before we talk about the quantum realm, we must talk about one of the most smallest things in our universe, atoms. Come with me as we will explore the great mysteries of our universe. Buckle up, wear your cosmic seatbelt, because it's time for quantum time. Before we actually dive into quantum physics, we must learn about atoms. Well, what are atoms in the first place? Well, atoms are small minuscule objects that make up almost everything. They are the basic unit of a chemical element. Everything that is made up of elements are made up of atoms. Now, let's get into the anatomy of an atom. An atom is made up of protons, neutrons, and electrons. Protons are positively charged and electrons are negatively charged, while neutrons have no charge. Protons and neutrons live in a very dense area called the nucleus, while the electron orbits the outside of an atom. Electrons orbit the atom at super high speeds. In fact, an electron orbits a hydrogen atom at about 2,200 kilometers per second. Electrons are almost massless, while protons and neutrons have a mass of about 1.67 times 10 to the negative 24th grams. We call the mass of a proton one atomic mass unit, or 1 AMU. We also call the charge of a proton one elementary charge, or 1 E. The charge of a proton in coulombs is 1.6 times 10 to the negative 19th coulombs. The electron has a charge of negative 1 elementary charge. A neutron has no charge, so its charge is 0 elementary charge. Now we covered the basics of the atom, but one more side note. You've probably heard that the atom is mostly empty space. This is not true. When chemists say that an atom is mostly empty space, they mean that it is not filled with particles that have mass. So, what's in between the nucleus and an electron? Well, many quantum fields comprise in the space between the nucleus and the electron. Also, gravitational waves exist between them, and virtual particles being exchanged by protons and electrons. Okay, that may have sounded like a lot of complicated stuff, but don't worry, we'll address all of those things in the future. Now, you can't see quantum fields or gravitational waves, so all the pictures you see of an atom are fairly correct, for now. So, what's the evidence for the existence of atoms? Well, it was Albert Einstein who proved the existence of atoms through a phenomenon called Brownian motion. Many scientists noticed that if you put pollen in a glass of water, it would start to move in random directions, as if it's alive. Einstein solved this problem by imagining atoms in the water. The atoms in the water were smashing into the pollen, causing it to jiggle. There came even more evidence for atoms after Einstein, and we've even seen them through high-efficient microscopes called electron microscopes. Einstein published his paper on Brownian motion in 1905, and that was really up an atom. See what I did there? Today you learned about atoms and the particles that make them up. You learned about the charge of protons, neutrons, and electrons. You learned about Brownian motion and atomic mass units. Thanks for watching. And our next episode will be on the Bohr model of the atom. But before I sign off, why can't you trust atoms? Because they make up almost everything. Thanks for watching. Remember to like and subscribe, and I'll see you on the next episode.